Welcome to clickmyproject.com.
Now we discuss about reversible data hiding in encrypted images by reserving room before encryption. In this process, we use reserving room before encryption for data hiding. The reserving room encryption will be helpful to improve the data hiding process accuracy. Here, the high amount of data will be hiding during the data hiding process. The reserving room is allocated a space of images before the encryption. Here, some space will be allocated for data hiding before the encryption of the image. It will be help to increase the data hiding capacity in input image. Here, the reserving room is getting the low value pixel for hiding the data. During the encryption process, the reserving room does not done the encryption process. So the data was hiding easily in reserving room. In this process, advantage is if we get data hiding, if we want data, then we use only data hiding key. If want the image, we will give the image key for retrieve the image. It is not the process for line by line. For that reason, it is very advantage process. Now here we will give the two important keys for security purpose. Now the encryption process, we give the user key by center side, and also the data hiding key will be given by center for hiding the data. The encryption process will be done by AES algorithm. The AES algorithm, the key generation based on the image size, and then using that key, it will be encrypt the input image, and we get the encryption process. The encryption key will secure the encryption process. The encryption will be hiding through the data, and during the decryption process, the key will be checking, and if the key will be matched to our input process, then it will be decrypt the input image. And the data hiding, the reversible data hiding and NSP will be used. The NSP technique is help to embed the data into the reversing room. The RDH is help to hiding the key with data. So if we give the wrong key during the retrieval process, the data will be getting wrongly classified. So that key will be give the security purpose. Security will be increased in the process. The reversing room before encryption, it is improve the BSNR value for the output image. It is denote the output process will be less distortion of the input image, because it will be allocated some space for data hiding. So that reason there is no distortion is less into the input process. It is the flow diagram for our process. In this flow diagram, first we give the input image. The input image is any type of natural image is given. The input images will going to the reserving room. During the reserving room, the space will be allocated by the center, and after the space will be allocated, that image will be encrypted by the encryption key. The AES algorithm will be used to the encryption process. After the encryption, the encryption image will be go to data embedding. Here, the data was embedding by LSP and RTH with campaign of embedding key, and embedding that data will be in reserving room. After the receiving data will be embedding, it will be go to the receiver side. The receiver side, if you give the encryption key, then we get the original image, or else if we give the data hiding key, we will get the original data. It is the advantage of this process. In previous method, that is not possible to retrieve the both at any time. It is the one by one process. First we decrypt the image, and after we will get the data in existing method. So it is the advantage of our proposed work. Now we see to demo of our process. Open the MATLAB code and then right click the main.dem and run the file. And this is the window for the sender side. First browse the input image from the dataset or any other from the image. Then load that image, and then give the encryption key of the process, and here give the data length, and here give the key length. Here I will give the key length is 30. If we reduce the key length, and then the key will be setting the amount of this length of this much of key will be entered. The 13 is the final limit of the key. Now we encrypt the images, and it is the encrypted image of our input image. During the encryption, the room will be allocated for the data hiding. Here we will type the data or load the data, and then give the data hiding key, and it is the maximum data length for input image. If we change the data length, that much amount of data will be embedding, and press the embedding button, it will be embedding, and then give the name for the embedding image, and then put save to save the image, and press this button for exit this process and going to next process. And here the sender side. Now first we give the image retrieval key, and wrong key I will give you. If we give the wrong key, in the decryption process, the key is not matched. Now I will give the correct key. The data was retrieval, the image was retrieval, and the PSM value is 40. Here it is shows how much amount of resources will be done in the process during the data hiding. The 40 decibel is the limited value for the BSN distortion level. It shows the best of data hiding is done here, and visually also shows that what is the data hiding image will be changing during the data hiding. Now I will give the data hiding key at wrong, and then retrieve the data. It will not be give the data correctly. Then I will give the correct data hiding key. The data was retrieved. Now the key is correct. The data was retrieved. Thank you.